So let's talk about what an absolute value is. Okay, so this absolute value of -3 that you see right here. Okay, do you see it? It's special types of brackets. There's special type. When you see an absolute value, it has a very special type of brackets. It's like, I like to explain it like jail. So with jail, the purpose of jail, what is the purpose of going to jail? Not to say that it happens. What's the purpose of jail? And then to do what with you? Rehabilitate you. Okay? So, unfortunately, sometimes good people go to jail. Sometimes bad people go to jail. Right? You get both. But the goal is that everybody, when they leave, should be rehabilitated and come out positive. Right? That's what an absolute value does. The absolute value is actually defined as the distance to 0. And distance is always positive. So for example, if I want the absolute value of -3, okay, the absolute value of -3 would be 3 because the distance to 0 is 3. Because the distance from -3 to 0 is 3. That's the definition of absolute value. So it always comes out as a positive. So absolute value is the distance from a number to 0. It'll always be a positive number. We take the positive of whatever's inside the brackets, okay? So when we treat these types of brackets just like you treat any type of bracket in BEDMAS. So you evaluate what's inside the brackets first. It's just like a special type of bracket. But what comes out of it is always positive. So absolute value of -3 is 3. Let's write one more underneath this. Absolute value of +3. What's the distance from 3 to 0? Still 3, okay? Whether it's positive or negative, it always comes out as a positive. That's an absolute value. You got me? Okay, good. So, this guy, negative absolute value of 9. This time, is the negative inside or on the outside? Yeah, notice that this is on the outside. So is it going to change the sign of what's inside the absolute value? No. Absolute value of 9, we can replace it with regular brackets. What's the absolute value of 9? Just 9. And 9 times -1? -9. Because that negative is on the outside. So it's only if the negative is on the inside, right? Does it come out positive? So to treat this like regular BEDMAS, we simplify inside first. 8 minus 12, -4, and absolute value of -4 is 4. Okay, can you do this on your calculator? Yes. So before we solve the rest of these, down here it tells you how to punch this in on your calculator if you want to grab it. Okay, so clear. The easiest way is push your math button. Okay, and 1 over to number. So right arrow over to number, and it's the very first one, which is absolute value. Okay, now there's, depending on your calculator, if you have a newer calculator, it'll look like this. It'll actually give you those vertical lines. If you have an older calculator, it'll say ABS. Oops. Try this again. ABS, and I'll give you a bracket. So if we were like double checking the 8 minus 12, we type that in, and there it is. So you would have to close your bracket like that if you have an older version, or the older ones. If you lose anything in your calculator, there is a catalog. So do you know where the catalog is? Take a look. Where's the word catalog? Second 0. Okay, second 0, it's the very first one because it's alphabetical. So that's nice. So if you forget where to find absolute value, you can always look in your catalog as all the different things it can do. So anyways. All right, so let's look at this guy. If I wanted to type this one in, I would have to push math, number 1, 3, get out of my absolute value, or close the bracket if you have an older version, minus And then math, number 1, put in my negative 7, and then close the bracket if you have an older version, or push arrow if you have a newer version. So that's how that would look, which equals negative 4. Do we agree with that? Let's think about this. What's the absolute value of 3?
3.
Minus, what's the absolute value of negative 7? Just 7. 3 minus 7? Negative 4. Okay? You can have an absolute value and an absolute value. So how do we deal with brackets inside brackets? It's like Inception. It's a good movie. It's becoming an old one now. We have brackets inside brackets. Like if I had 2 plus 3 times 6 plus 5, how would I start that? Right, you work from the inside out. You know what to do. You just didn't. Yeah, okay, so you know what to do. 7 minus, what's the absolute value of negative 7? This guy. 7. 7 minus 7? 0. Absolute value of 0? 0. Okay, do you want to try this one? Okay, try the last one. You can use your calculator to check if you want. Or do it by hand. If you did this by hand, you'd want to work from the inside out, right? So I would start with the negative absolute value of 6 minus 15, negative 9, right? Minus 2 times absolute value of 4 minus 9. Okay, this is a negative 5. Absolute value of negative 5. So when we evaluate, I'm going to use square brackets for this whole thing because it's so many brackets. When you evaluate absolute value, you can actually replace it with round brackets. So negative times, what's the absolute value of negative 9? 9 minus 2 times, what's the absolute value of negative 5? 5. So instead we have 4 times negative 9 minus 10, or 4 times negative 19, negative 76. So if you got that, you got it right. Okay, just so many brackets. It's messy. So the final answer can be negative, but nothing coming out of the absolute value can be negative, right? Your final answer can be, things outside of the absolute value can be, but whatever comes out of an absolute value is positive. So if you have y equals the absolute value of x, we're going to actually graph that right away. If it's positive, we leave it alone. So for example, if you have the absolute value of negative 3, oops, sorry, positive, if it's positive. If the absolute value of 3, okay, that equals 3. Did we actually need the absolute value if it was a positive number? No. So that means that if x is greater than or equal to 0, if it's a positive number, then the absolute value of x would equal to, would you need those absolute value brackets? If we know x is greater than or equal to 0, if it's positive. No, you wouldn't need it. You could just, it equals x, right? So if it's a positive number, we can just leave it alone. We can get rid of the absolute value brackets. They're not needed. If it's a negative, so for example, absolute value of negative 3, what would we want to do to that? Make it positive. Okay, so let's think about an operation I can do to negative 3 to make it a positive number. What could I do to the negative 3, just negative 3 itself, the number, to make it a positive number? Multiply by negative 1. We're going to multiply by negative 1. Okay? And that, would you agree that negative 3 is positive 3? Yeah. So that means if x is less than 0, if x is a negative number, okay, then the absolute value of x equals negative x. Equals negative x. If x is less than 0. So if x is a negative number, okay, if x is a negative number, we can multiply it by -1 for it to equal a positive. So if only if x is a negative number. That's the key. If I put in -2, then I can go -2 comes out +2. You with me? This is where it gets kind of abstracty. I don't know if that's a word. Okay, how do you make something negative? You multiply it by -1. And two different rules. We call this, so there's two different rules depending on the sign, right? We call this a piecewise function. Piecewise function, because there's two different situations for x, depending if it's positive or if it's negative. If it's positive, we can leave it alone. If it's negative, we have to multiply it by a negative to make it a positive. Okay? Alrighty. Let's go on. So this is what a piecewise function looks like. Okay? So there's two situations for x. The absolute value of x, if it's positive, if it's greater than or equal to 0, we don't need the absolute values. We can just drop them. Right? So this means positive. If it's negative, less than 0, okay, then we'd have to multiply it by a negative to make it a positive. Okay? So you have those two situations depending on if x is positive. There's a positive case and a negative case. Positive case and a negative case. Notice something here. Notice that the equal to symbol is only with one of them. Like underneath the inequality, greater than or equal to, and the other one's just less than. Let me zoom in here. Okay. Okay. Do you see what I'm talking about? I'm talking about this little equal to right down there. Okay. Notice that's only with the top one, not the bottom. So we put the equal to 0 because where does 0 go? Well, is 0 negative or positive? Is it? Are you positive that it's positive? Or can it kind of, yeah, it's kind of neither, right? It's like, I don't know, Google that. Is it positive or negative? I don't think it's either. I think 0 is like a really special number. So we just put it with one of them. It doesn't matter which one. It can go with the negative case or the positive case because it's just special. Notice that the equal to symbol, because you don't want 0 in both places. So we only put it with one case. It doesn't matter which one. It is only with one of the cases. It doesn't matter which one, but we just put it with one of them. Okay? What does it say, Najir?
It says it's neither.
It's neither. Yes. Neither or neither? Neither. Okay. It's neither positive nor negative, so that's why we can put it with either. So if I want to write x minus 2 as a piecewise, yeah, go back. There you go. Let's write x minus 2 as a piecewise. So let's think about what would x have to be? What type of numbers would x have to be for it to be a positive inside the absolute value? So give me an x that would make it positive inside. 3. Give me another one. 4. 5. Okay, where is it starting? What number and larger? 2. Who said 2? 2, right? Because 2 would make the inside 0, right? Anything greater than 2, would you agree that anything greater than 2, the inside of the next question, absolute value of x minus 2, would make it a positive? Right? Really what you're solving is, when is x minus 2 greater than or equal to 0? When is it a positive number? How do you solve an inequality? Well, I add 2 to both sides when x is greater than 2. So that would be when it's positive, right? It's positive when, that's the positive case, when x is greater than or equal to 2. What's the negative case? When is it going to be a negative number? When it's what? 2 or less. So it's negative if x minus 2 is less than 0. Notice I didn't put the equal to symbol because we only apply it to one of them. Okay, or when, add 2 to both sides, when x is less than 2. Would you agree that any number less than 2 would make a negative inside the absolute value? So give me 1. Let's try 1. 1 minus 2, is that a negative? Yes. Okay, so how do we write the piecewise? So we want to write the two cases. Okay, the two cases is, if it's a positive, do you need the absolute value symbol? No. So you would just drop it. It equals to just x minus 2 if, when was it positive? If x is greater than or equal to 2. Do you see how these lessons are like, you don't want to miss this class? There's a lot coming at you. Okay, the negative case. How do we make a negative into a positive? Multiply by -1. So we would take the x minus 2 if it's a negative number and multiply by a negative. Oops. If x is less than 2. So we're going to have the positive case and the negative case. All right, so positive case, we leave it alone. It's already positive. We don't actually need the absolute values. We can drop them. The negative case, if it's a negative number, we have to multiply it by a negative to make it a positive. So it's equal to the absolute value. Okay, so that's a piecewise function. Yay! We're going to practice more, I promise. It's a lot. Let's start by graphing. So I'm going to zoom out. All right. We can graph by hand. We can also check it on our calculator after. Do you want to do it on your calculator first so you can see how cool it looks? So remember, can you put a negative inside? Inside, like can x be a negative number? Can you put a negative inside an absolute value? Yes, but whatever comes out will always be positive. Okay, so remember that. Let's go to your graphing calculator. Clear what's there. Math, number, 1, and then x. And if your windows are off, go zoom 6. Clear your drawings. Okay. It's a V. A flying V. So, does that make sense? What did we say about x? Can you put a negative x in? Can a negative go inside the absolute value, be your input? Yeah. But output will always be positive, which is why y is always greater than 0. Okay? So, absolute value of -5 was equal to 5. Absolute value of -4, 4. Absolute value of -3. It's too easy. We should just draw it, or what? Or do you know what the absolute value? Do you know what to do here? What's the next number? 3. The next one is 2, because the absolute value of -2 is 2. Absolute value of -1, 1. Out comes positive, right? Absolute value of 0, 0. Absolute value of 1, 1. Okay, so these are our points that we're plotting. -5 was 5. I can count, I think. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. -4 was 4. 3, 2, 1, 0. 1, 2, 3, 4, 5. Okay, so those are the points that we want to connect. I want you to think about the equation before the absolute value. In a sense. Let's just draw this first. I'm going to do a lot of graphing this unit, and graphing is going to show up on your quizzes. So you have to do nice points, not just like rough sketches. You're going to have to be able to like make nice graphs. Okay, so that's our equation y equals absolute value of x. Think about the equation before the absolute value. If you were to graph y equals x, okay, the graph of y equals x. What's the difference between this graph and the graph y equals x? Do you need to graph it on your calculator to know what that looks like?
Yeah.
Y-intercept 0, slope of 1. It's a straight line going from quadrant what to what quadrant what? 3 to 1. So it actually looks like this, right? I'm going to draw a dotted line here. Okay. This would be the line y equals x before you take an absolute value. So y, like this part, stay the same. Why did that part stay the same? Well, that part of the equation, the y values were already positive. Absolute value positive, it stays the same. What happens here? How would you describe the transformation? The transformation is going on. It's less than 0. It's a reflection in the x-axis. Okay, it's a reflection in the x-axis because your negative y values, when you take the absolute value of a negative, it's going to turn into a positive. So it's reflected. So any negative y values, if you look at a graph before an absolute value, they're going to be reflected and become positive y values. Okay, let's think of this function, this part of the graph here. This part of the graph is the same as y equals x if x was greater than 0. That part stayed the same. You can see they stayed the same. We don't need the absolute value because they're the same. This side, though, is equal to, what would be the equation of that line when it's less than 0? Negative x if x is less than 0. Because we have to take the x value, multiply by negative 1 to make it a positive because it's already a negative. And if you look at the slope of that line, would you agree the slope of that line is negative 1? mx plus b? Remember that stuff? Yay. Okay, one more thing, that's called a vertex. And that's where the sign switches. From positive case to negative case. Okay? Okay, so there's a whole bunch of like what I just said explained here. You can read through it if you want. I already talked about it, so I don't want to read what I just said. So you can read it if you want. Some nice evening reading before bed. Right? Totally? Okay. Let's do some more graphics. Okay, consider the function y equals the absolute value of 2x minus 3. Determine the y-intercept and x-intercept. Okay, let's do that first. How should I do this by hand or not? Okay, I'm going to show you how to sketch this by hand. So if I wanted to sketch the absolute value of 2x minus 3, the easiest thing to do first is sketch y equals 2x minus 3 without the absolute value. Okay? Grade 10 math. Do you remember how to do that? What's your y-intercept of that graph? Negative 3. Okay, here's my y-intercept. What's the 2? Is your slope. And if we want it as a fraction, it's 2 over 1. Right, make it a fraction. 2 is the same thing as 2 over 1. We do that because we want to use rise over run. So we go up, 2, right, 1. Remember this? I'm doing that right now with the grade 10s. Seems like so long ago, doesn't it? Okay, so this is the original function. I'm going to draw this as a dotted line. Okay, so that's the original function before the absolute value. So what part of the graph is going to stay the same? when we take the absolute value? When our y values were? Are you lost already? What part will stay the same when you take an absolute value? When the y values are positive or negative? Positive. When the y values are positive, the graph is going to stay the same. This part will stay the same. Because the absolute value of a positive is a positive. So that part stays the same. Where will it switch? So where does the sign switch then? Well, it does at -3. But where is y equal to 0? Where does it move from positive y values to negative y values? What do you call that? The x-intercept. And what is the x-intercept in this case? So set y to 0. What's the x-intercept? No. So setting y to 0, solving for x. 3/2, so add 3, right? Then divide by 2. 1.5. Okay, do you agree? Do you see that it's 1.5 right there? Your x-intercept is where the y values, the signs switch from positive to negative. Okay, so that's going to be important. So 3/2, or 1.5, is going to be important. That's always the point you're using in your piecewise function we're going to write. Okay, because that's where it changes from a positive to negative. So where are the y values negative? So therefore, where were the y values negative? So where the y values are negative, they now become positive, or reflected in the x-axis when x is less than 3/2. Okay, so what we want to do is we want to reflect what we see. I'll let you write that down and then we'll draw it together. Where the y values are negative on the original function before the absolute value, I'm talking about the equation y equals 2x minus 3, they're going to become positive now. Because if you take an absolute value of a negative, it becomes positive. So we're reflecting that in the x-axis. So when x is less than 3/2, so this point right down here is now up here. Right? We're literally doing a reflection. The y-intercept of -3 is now 3. Okay, this point here of -5, -1, -5 is -1, 5. We're going to literally reflect it. All these points are reflected. See, I know you could plug this into your calculator. I know you can look up a table of values, but can you understand what's happening? That's why we're going through all these steps. Okay, so there's the green graph is our graph of absolute value of 2x minus 3. Okay, I'll write one more note. Where the y values were positive, they stayed the same, right? They stayed positive. And that was when x was greater than or equal to 3/2. Okay. So this side of the line, where it was positive, if x was greater than 3/2, did you need the absolute value brackets? Or was that the exact same line as 2x minus 3? It's the same, right? As long as it's greater than that, it's positive. On this side, if x is less than 3/2, what would you have to do with your equation? If 2x minus 3 is a negative, you'd have to multiply it by negative 1. So that would be the equation, negative 2x minus 3. Think about this. If I distribute the negative, it becomes negative 2x plus 3, right? Would you agree with that? Distributive property? So it's saying it's a slope of negative 2 and a y-intercept of 3. Do you see that? Y-intercept of 3 and a slope of negative 2, right? The equation switches. All the signs switch. So you can also think of it as you distribute the negative, negative 2x plus 3. So there's your y-intercept of positive 3 for that side of the line. And here's my slope now of negative 2. Got it? Sort of? I don't know. It's a lot of information at you. Okay, so what's the piecewise? It stays positive if what? We don't need the absolute value if x is greater than or equal to 3 over 2. And we multiply it by negative 1 if it's a negative, so that's when x is less than 3 over 2. Okay. They wanted us to do a couple of things. Can you scroll to the top for a second here? So what was the y-intercept of the absolute value function now? What's the y-intercept of the absolute value function? 3. Yeah, that's 3. And you can find that by, remember y-intercept is when x is 0. So you could have just plugged in x is 0 into your absolute value. And you would have had absolute value of negative 3, which is 3. Okay? They asked us to find the x-intercept. Did we do that? Yeah, we did that. Right here. Domain of this graph. What's the domain of the absolute value? X is an element of the real numbers. What's the range? Greater than or equal to 0. Okay? And pretty much, well, all the ones we study will have that domain and range. Okay? We'll always have that domain and range. And then we did piecewise. All right. Okay, one more example, and then you're going to try one on your own, and then we're done. Consider the absolute value function negative 3x plus 1. Where does the function switch signs? So where do the y values move from positive to negative? At what point? At the x intercept, right? The x-intercept is when y is 0. So that's going to be the turning point, or the vertex of the graph, right? That's where the vertex is. So we're going to set y to 0. Now, can I ask you a question? If I make y 0 here in our equation with the absolute value, do we need the absolute value symbol? No, because if that's equal to 0, absolute value of 0, do you need the absolute values? It's still 0. No. So we're really solving this. So first step, minus 1, and then divide by negative 3, and it equals 1/3. So your x equals 1/3, right there, somewhere like that, is going to be the x-intercept. That's the turning point. That's the vertex of our v. Okay? If we sketch this function originally, sometimes I find that very helpful for 2 reasons. It also helps with your piecewise. So if we graph this y equals without the absolute value, where would I start with that? Y-intercept is negative 1, and slope is what? Negative 3 over 1. So we're going to go down 3, right 1. Down 3, right 1. Do you remember that unit? You also did it in like grade 9. I know that. I'm not sure if it's in grade 8. Is it in grade 8? Okay, so I'm going to draw that dotted line. So that's going to be helpful. So you can see, where is it going to stay the same? Wherever it's already above the x-axis. Okay, so we can now trace over the part that's already wait a second. Something's not right. Oh no, we're good. We're good. No, but why did my x-intercept go there? Give me a second. -1, 1/3. What did I do wrong? Oh, Johnson. Do you see it? You don't see what I did wrong? Where's my y-intercept? Is it -1? +1. I hope you never copied me. That would be sad. Sorry. Should really buy some more erasers. Okay, so these are all going up 3, right 1. Something like that. My line's not very good. Okay, I'm going to redraw it. That's awful. Because I need a slope of F3. Down 3, right 1, down 3, right 1. Those are good. 3, 3, and 3. So let's get rid of this guy. Like, it should be going through our x-intercept, and it wasn't. There we go. Okay, so where is it going to stay the same? Where the y values were positive. So now I'm going to trace over this part all the way to my x-intercept. That part stays the same. Those had positive y values. Right? What part is reflected when the y values were negative? Because out comes a positive. So this point down here that was -2 is now going to be a +2. The point that was -5, +5. The y value down here. So notice the x value stays the same. We're just flipping the y value, reflecting the y value. And then 8. So it should look like this. Okay, so I literally look here and reflect it. This is 2 down, it's 2 up. Anything that's below everything should always be above the axis while we're done. Okay? All right, what's the domain? X is, for the red graph, absolute value graph. Element of the reals, right? It can be, you can put anything inside the absolute value. What comes out? Y is greater than or equal to 0. Okay, let's write this as a piecewise. Now this one's a little bit different. Not really. So where does the graph stay the same? Where did we not reflect it? Where were the y values already positive in the original function? If x was what? Greater than or less than? Nope. It was less than or equal to 1/3. Right? Look at the graph. Where was it already above the x-axis? Don't be fooled by that negative slope. Right? It was a positive. Y values here when x was less than, right? Give me a number less than 1/3. Okay, let's do a nice one. -1. Okay? If you plug in -1, -3 times -1 is 3 plus 1 is 4. The y values were positive when it was less than, right? They were already above. Look at that dotted line. That's going to help you with your piecewise. Where was it positive before? Where was it above the x-axis before we took the absolute value? Okay, and then where was it negative originally? Where did we reflect it? If x is greater than 1/3, right? See this part here? Where was this part reflected? That's when x was greater than 1/3. Then we reflect it. Okay, where were the y values? Where were they reflected? Where was the graph reflected or had negative y values or below the x-axis? Where was it below? Originally before the, that's why we draw the equation before the absolute value. So you can see where did it change and where did it stay the same. The top is where did it stay the same? Or where were your y values positive? Already. Above the x-axis. Where was it above the x-axis already? It was above the x-axis and it's less this portion here. Less than 3 over 2. Alrighty? Okay. There's one more on the next page I want you to try on your own. So I'd like you to sketch it and write the piecewise of it. So start by sketching before absolute value, little mx plus b, and then write the piecewise. Okay, so let's pause it here. Okay, so your absolute value graph should look like this. You also check your graph. Yeah? Yay? Okay, so the question is, did you get your piecewise right? It's the absolute value of 3x minus 6. Where did it stay the same? Oopsie. That was an ugly bracket. If you struggle with these brackets, it's okay. Do your best. I'm not going to dock you marks because you can't draw a proper bracket. Or maybe I should. Okay, so where does it stay the same? Where do we drop the absolute value? It's not needed. If x is what? Ryan, what did you get?
Plus equals greater than or equal to -2.
Okay, let's think about this. Is it less than or greater than? Because where did it stay the same? Where are the graph? Think about where do the line of the graph intersect? Where does the absolute value graph and the just linear graph, where do they intersect? Where are they the same line? When x is less than or equal to -2. Okay? Right? Here, they're intersecting. That's where it stayed the same. Then, what did I just do there? I don't know. Where did we have to multiply it by -1? Where was it already a negative value? So we multiply it by -1 to make it a positive. Where did we reflect it? Oops, I forgot the equal to symbol. When x is greater than -2. So these values down here is where it's reflected. When x is greater than -2. Got it? Okay. And only one of them will have an equal to symbol. It doesn't matter which one, just only one. Okay, we'll have the equal to symbol. That's what you should have. Good? Now, if you have a graphing calculator, you can kind of see that if we were to graph absolute value of -3x minus 6, and then you could graph -3x minus 6 without the absolute value. What I would do is I would probably change the line that's going to be not the absolute value, maybe to a dotted line. So you can change it. You have different. You keep pushing enter on the older versions. Okay, so that one's solid, one's dotted. So what's the original graph? What's the absolute value? And then you can see them. So you can see, okay, there's my absolute value graph that I'm drawing, and there's the original graph. Okay, so where did it stay the same? Where are they intersecting? They're intersecting less than 2. Where was it reflected? You can see where is it reflected? Greater than -2. I said 2, but -2. Okay, so you graph the 2, and you can see where did it stay the same? Where did it reflect? Where were they positive? Where were they negative? That's it for today's lesson. Oh, okay, now there's a little thing on your notes. Okay, see this? It's actually answers to help you with your homework. So your assignment is on the front of your workbook. which is page. Okay, the 363 numbers 1 to 7. Those are just like simple absolute values. And then page 375 to 379. Numbers 1 to 6, 9, 11 AB. And then also, this is really important, this part. Write each of number 6 as a piecewise function. Your textbook doesn't really have piecewise practice. So what we've done is in your notes, at the bottom, these are the answers to number 6. So what I want you to do is when you get to number 6, also write them as piecewise. You can check your answers here. If you that so you'll see the graph and what it should be as a piecewise function. Okay? Because obviously your textbook doesn't do that. Sound good? Yay? Question?
Can we go on our quizzes 101 right now?
Can you what?
Can we go over our quizzes like 101?
No. So that people don't write.
See what is wrong.